All right, so we're going to do some independent events. An independent event means that you can have choice A from happening, choice B from happening, but they might have something that overlaps in the middle where they both happen at the same time. They also will talk about mutually exclusive events where you have type A and type B, but they don't ever overlap each other. If they're independent, they might overlap and you might have both occur at the same time. So first one, we are going to do the probability of A and B happening at the same time. In order to find the probability of A and B happening at the same time, we're just going to find the probability of A and multiply it by the probability of B. So it says, suppose that A and B are independent events such that P, and this one it has the bar over the top means not A, is 70%. Well, if my probability of not having A is 70%, what would be the probability of A happening? The probability is not 30%, exactly. It's not going to happen at 70%, so if I take 100% minus 70%, 30% is the probability it will happen. They told us the probability B will happen is 10%, so find the probability of A and B. We're just going to multiply those two together. So 0.30 times 0.10 would give us 0.03. The second part of that wants us to find the probability of A or B. If I'm going to find the probability of A or B, I'm going to do the probability of A plus the probability of B minus the probability of A and B. Smoosh that whole formula in there. And so to figure this one out, the probability of A was 30% plus the probability of B was 10%. I'm going to subtract the probability of A and B, which is what we found up here, 0.03 then. And I would get 0.37. So we have a 3% probability that both of them will happen, A and B, a 37% probability that either A or B will happen, in other words, both of them happening at the same time. All right, so number 2, pretty much the same thing. If I can get rid of that little deal, there we go. Suppose that A and B are independent events such that P, the probability of A not happening is 50%, so the probability of A actually happening would also be 50%, right? We want to find, first of all, the probability of A and B. So we're going to take the probability of A times the probability of B. So 0.5 times 0.2. We get 0.1. A point almost looks like a point. 0.1. A or B. Can A happen or B happen? So we have to do the probability of A plus the probability of B minus the probability of A and B. So probability of A was 0.5, probability of B was 0.2, probability of A and B was 0.1. So 0.5 plus 0.2 minus 0.1 gives us 0.6. 0.6. So on number 3, suppose that A and B are independent events such that the probability of A not happening is 10%, which means the probability of A actually happening would be 90%, so 0.90. If I'm going to find the probability of A and B, what would I do?
Or, yeah, you. 90 times.
We're going to multiply them. 0.90 times 0.60, right? A and B happening at the same time, we got to multiply them together. We get 0.54. If I'm going to find the probability of A or B, what would I do? Yep.
0.60 minus 0.54.
Exactly. I take the probability of A plus the probability of B, and I subtract the probability of both of them happening at the same time.
96.
And I get, I lost my answer. 0.96, okay. 0.96, good, that's what I got.